Every second, our universe is crying out with light. In millions of galaxies scattered across the observable cosmos, vast clouds of hydrogen gas are collapsing under their own gravity. Temperatures reach millions of degrees, pressures become unimaginable, and nuclear fusion ignites. A new star is born. We live in an era of cosmic abundance. Scientists call this the Stelliferous Era, the age of stars. It is an epoch defined by creation, heat, and the continuous recycling of matter. But this era is not permanent. It is a temporary anomaly in the history of the cosmos. There will come a day when the cosmic nurseries will run empty, the gas will dry up, the cosmic fires will begin to fade, and the very last star in the universe will be born. What happens when the universe loses its ability to create light? How does reality transform when the cosmos enters its long, slow journey toward absolute silence? Today, we will analyze the physics behind the end of stellar creation. We will look at the final generation of stars, explore the dark era of degeneration, and understand why the silence of the universe is an inevitable law of thermodynamics. The depletion of the cosmic fuel. To understand why the universe must go silent, we have to look at stars as cosmic engines. Like any engine, they require fuel. That fuel is hydrogen, the simplest and most abundant element created during the Big Bang. When a star shines, it fuses hydrogen into helium. When that star dies, it sheds its outer layers back into the galaxy, rich with new, heavier elements like carbon, iron, and oxygen. This material is then used to build the next generation of stars and planets. This is the circle of cosmic life. However, this recycling process is highly inefficient. Every time a star burns fuel, a significant portion of that hydrogen is permanently locked away inside the dead cores of white dwarfs and neutron stars. It is removed from the cosmic economy forever. Furthermore, as galaxies accelerate away from each other due to dark energy, the intergalactic gas reservoirs become too diffuse to collapse into new stars. Astronomers have already measured the trend. Peak star formation in our universe occurred roughly 10 billion years ago. Since then, the rate of new star creation has been steadily declining. We are already living in a dying ecosystem. The universe is slowly using up its non-renewable stellar currency. The last generation, the reign of the red dwarfs. As the great hydrogen clouds disappear, the massive, brilliant blue and white stars, the ones that live fast and die in spectacular supernovae, will disappear first. Within a few 100 billion years, they will be gone completely. The universe will be left with only one type of star, red dwarfs. Red dwarfs are the minimalist survivalists of the cosmos. They are small, possessing only a fraction of the mass of our sun. But because they are small, their internal convection currents constantly mix their core, allowing them to burn their hydrogen fuel with extreme efficiency. While our sun will die in about 5 billion years, a low-mass red dwarf can live for up to 10 trillion years. This will be the final generation of stars. The Milky Way, which will have long merged with the Andromeda Galaxy, will become a dim, crimson shadow of its former self. There will be no grand nebulae, no brilliant star clusters. Just a trillion small red embers keeping watch over a freezing universe. But eventually, even the red dwarfs will exhaust their fuel. They do not explode, they simply fade, shrinking into cold, dense spheres of helium and carbon known as black dwarfs. Roughly 100 trillion years from now, the last red dwarf will burn its final atom of hydrogen. The lights of the universe will officially go out. The Degenerate Era, the mechanics of decay. With the death of the last star, the universe enters the Degenerate Era. The cosmos is no longer defined by light and radiation, but by gravity and cold matter. The only remaining structures in the universe will be the remnants of the Stelliferous Era: white dwarfs, neutron stars, and black holes. They will drift through an endless, freezing vacuum. Without the light of stars, planets will freeze to temperatures near absolute zero. Galaxies will lose their structure. Over vast stretches of time, close gravitational encounters will fling planets out into the dark void, while dead stellar cores will either cascade into the supermassive black holes at the center of galaxies or be ejected into deep space. But the physics of this era get even darker. According to many modern grand unified theories in physics, matter itself may not be permanent. Protons, the fundamental building blocks of every atom in the universe, are projected to decay. The timeline for proton decay is immense, estimated around 10 to the 34th power to 10 to the 40th power years. But in the deep future, time is all the universe has. Slowly, atom by atom, the dead planets, the black dwarfs, and the neutron stars will simply dissolve. Their solid matter will turn into subatomic particles and bursts of radiation, bleeding away into the expanding void. The universe will physically disintegrate from the inside out. The ultimate silence, the black hole era and beyond. By the year 10 to the power of 40, the universe will be entirely unrecognizable. All solid matter is gone. The only entities left inhabiting the cosmos will be black holes. This is the black hole era. For unimaginable eons, these dark monsters will be the absolute masters of space. They will slowly swallow whatever stray particles are left in the void. But even black holes are subject to the laws of thermodynamics. As discovered by Stephen Hawking, black holes slowly lose mass through a quantum process called Hawking radiation. A black hole with the mass of our Sun will take 10 to the power of 67 years to evaporate. The supermassive black holes at the centers of galaxies will take 10 to the 100th power years. One by one, from the smallest to the largest, the black holes will slowly shrink, wither, and vanish into the dark vacuum. When the final black hole evaporates, the universe enters its final stage, the dark era. There is no heat, there is no structure, there is no matter. The universe becomes an infinitely large, flat, cold sea of stray photons and electrons, separated by distances so vast they will never interact again. The temperature drops to absolute zero. Entropy has won. The value of the present. When we look at the timeline of our universe, it is easy to feel a sense of scientific nihilism. The era of stars, light, and life is just a microscopic fraction of the total lifespan of the cosmos, a brief, bright flash before an eternity of darkness. But science also teaches us that value is defined by scarcity. The fact that we live right now, in the golden age of stellar creation, where the sky is full of stars and the universe is capable of nurturing life, is a profound cosmic privilege. We are the universe's way of experiencing its brief period of light before the long, inevitable silence. Thank you for exploring the deep future with me today. If you find the ultimate destiny of the universe fascinating, please leave a comment below. What part of the cosmic timeline surprises you the most? Don't forget to like, subscribe, and I will see you in the next room.